Hello folks, how are you? I hope like everyone is doing good. So today I'm going to talk about lazy installation exception in Spring JPA or like SpringBoot JPA. Okay, so basically you will get this kind of exception. So when you are using like SpringBoot JPA like one to many association, so you will get like this could not initialize the proxy and no session. Okay, so why this exception will occur? So how to resolve this issue, and after that so what are the possibilities are there, so which is the best one, so I'm going to explain in this video. Okay, so before that I would like to discuss what is eager loading and lazy loading. So first of all, like eager loading is a design pattern in which data installation occurs on the spot. So that means like in eager loading the data loading happens at the time of their parent is fetched from the database. Okay, so that means like so the child data will be loading happens at the time of parent data is fetched from the database. By default, so many to one and one to one are like eager loading. Okay, so if I are using like many to one and one to one association, so by default this is eager loading, this two. And coming to the lazy loading is like associated data loads only when we explicitly call like getter or size method. The data loading won't happens, so the child data loading won't happens at the time of their parent data is fetched from the database. So that is lazy loading. So when exactly this lazy loading happens is, so you have to explicitly call, okay, the getter method or like size method, so then only this lazy loading will be happen. So getter method or like if you have like any find method or like find all method, then the lazy loading will be happen. So by default, like if you are using like many to many or like one to many association, then by default that association will use lazy loading. And and after that, lazy initialization exception. So lazy initialization exception basically will occur when you are trying to access to a lazy loaded object outside of the persistent context of an open hibernate session will result in this exception. So first of all, like what is lazy loaded? So lazy loaded means like lazy loaded object means like we already discussed about the lazy loaded object. So if you are trying to access lazy loaded object outside this persistent context, okay, so persistent context means like so whenever like your application using like the database, the persistent context will be happen within the same session. Okay, so if you are doing like this lazy loaded object outside this persistent context, that will cause to this lazy initialization exception here. And what are the solutions available? So we can use eager loading. Okay, so instead of we can use lazy loading, we can use eager loading here. And the next one is jpql, so that is Java persistence query language. So we can use this jpql left join here. And after that we have named entity graph and entity graph. Okay, so named entity graph are like another way to describe the query in a JPA 2.1. So we can use them to formulate the better performing queries. And after that we have transaction. Okay, so we can use at the rate of transaction on the service layer. So these are the solutions available. I'm going to explain one by one here. Okay, let's jump into the code here. Okay, here I have two entities. One is customer entity. Okay, so this customer entity will have one to many relationship. So the customer can purchase multiple items. Okay, so one to many association. Here I'm just using set items here, set of items here. And coming to the item, so I'm also using here many to one. Okay, so this item will have like many customers, so both things I'm using here. And after that we have a custom repository which will extend the JPA repository here. And after that I have item repository, so which is also going to be extend the JPA repository here. And finally I have a general service. In this service, what I'm doing is I'm just auto void this two repositories to make use of save method inside this JPA repository here. Okay, so I'm just created one customer here. I'm just saving the customer into the database. And after that I'm using item repository to save the items to the particular customer. I'm just passing the customer here. I just created two items here. After saving is done, okay, I'm trying to finding the all the customers by using this find all method inside this customer repository, and I'm just printing by using log here. So the log is related to the Lombok log, so we can simply use at the rate of SL4J log here. Now I'm going to make use the command line runner here. Inside this main method I'm just using run method. Inside this run method, so first of all I'm calling the service, general service, with the help of the auto void annotation, and after that I'm just calling the save method and I'm calling the find method. Okay, so if you see here, basically in the service method we are using the save method, right? So this customer is using one to many relationship here, and this customer data I'm trying to print in the find method, right? So now I'm expecting the lazy initialization exception because I'm trying to using lazy loaded object method here, right? So it has to be throw a lazy initialization exception here. Okay, let's start this. Okay, it's thrown some error, guys, so let's see this. So the error is the customer dot items could not initialize the proxy no session. Okay, and if you come down, so it is saying that, so throw lazy initialization exception here. So it's throwing the lazy initialization exception because we are trying to, okay, using the lazy loaded object here, right? So that is the reason it is throwing this exception. So how to overcome that lazy initialization exception? Okay, so the first solution is, so we can use eager loading here. Okay, so we have, by default it is a lazy loading, so I'm going to use eager loading here. So what will happen is, at the time of loading the parent data along with that parent entities data, it is also going to fetch the child entities data here. Okay, so let's start this. Okay, this time there is no exception, so it's printed like two SQL queries. One is like one select query related to the customer table, another select query is related to the items table. Okay, two queries is filed here, and so here I just printed the data. So one customer have like two items, so then it's perfectly working. So but is it recommended one? No, it's not recommended, because if you take like any real-time application, the real-time applications, if you take like any e-commerce application or like Amazon or Flipkart, so one customer can have like multiple items, right? So in that case it has to be fetch like all the child entities at the same time, right? So then it will impact the performance. So this is not recommended one. So we have like another approach. Okay, so I'm going to use jpql left join here. Okay, let's remove this code and let's go to customer repository. So in this repository, so I'm going to use @ query. Okay, so I'm going to write some query here. So let's write select distinct C from customer C. Okay, so left join fetch C dot items. Okay, and basically we need list of customer here and find all customers. That's it. Okay, so our query is ready here. So what I'm going to do is, in our service, instead of find all method, I'm going to use find all customers. Okay, and if you restart this, so it's going to use our jpql left join here. Okay, so if you see here, so only one select query is filed here, right? So if you come last here, you will see the left outer join. So with the help of the left outer join, so it is joined like two tables data. So there is no performance implications here. So you can simply use the jpql instead of eagle loading. Okay, so this is the better choice instead of eagle loading. And we have like one more solution. So I'm going to use named entity graph. Okay, so basically the entity graphs are like another way to describe a query in a jp 2.1. So we can use them to formulate like better performance queries. Okay, how we are going to write the entity graphs here, I'm going to explain. So let's go back to our find all customers. Here let's comment out this code. So to use this named entity graph, okay, so we have to go to our customer entity. Here we have named entity graph. Okay, so this named entity graph will have name. Okay, so inside this name we have to define, so what is the named entity graph. So this named entity graph will have the name, right? So that name will so let's say our table parent table is customer. The customer will have multiple items. Okay, and after that we have to define attribute nodes. Okay, so let's define attribute nodes. So this attribute nodes basically, so if you have like multiple attribute nodes, you can define the multiple attribute nodes here. Okay, so the attribute nodes is named attribute node here. Okay, so this named attribute node is basically so we have to define items here. Okay, so this is child attribute node. So that's it. So we have defined the named entity graph here. So this named entity graph name should be matched with your repository entity graph. We have to define one more entity graph here with the help of entity graph annotation. Okay, so inside this value we have to define customer dot items here, and let's take list of customer, and we have to provide like some name, find by name, but here we need to provide some okay parameter to this method to find out the customers. Okay, I just provided the name. With the help of the name I'm going to find out the all the customers. That's it. Now go back to your service. Here I'm going to use find by name. Okay, so the name is, I'm just hard coding, that is Tom, right? So this Tom, I just provided the name here, and you can just restart this application and let's see whether it's working or not. Okay, yeah, perfect. So if you see here, so here also only one select query is printed. So that means like, so only one select query is printed with the help of the left outer join here. Okay, and so we got it like output as customer and two items. So it's working fine. And so let me discuss about this entity graph. Okay, so basically the entity graphs, the default value of this entity graph annotation value is, if you go the entity graph annotation here, so here we have like a default value is fetch means like eager loading. Okay, and so eager loading means like it's going to be load like both tables data at a time, I mean on this spot. Okay, so if you are using other than the fetch type, so that means like that is lazy load, because here the fetch type is related to eager loading. Okay, and now, so we have seen like till now three solutions. Now finally I'm going to talk about the transactional. Okay, so let's comment out this, and let's go back to customer, and let's comment out this one as well, and let's stop the server and go back to your service. Okay, here we have a service, right? So what I'm going to do is I'm going to use at the rate of transactional. Okay, transactional, here I'm going to use the find all method. Okay, So all the operations will be happen within the same transaction. Okay, so you are saving and trying to find out all the information within the persistent context within the same transaction. Okay, now let's restart the server. Okay, so if you use like at the rate of transactional here, so it's working fine. So, but like here like it's like printed like two select queries, one is for customer, another one is for items. Okay, so this is also another approach, but the better one is you can use jpql jpql left outer join, or like we can use like entity graphs. Okay, that two approaches are like recommended one, so you can use either one. Okay, so that's it guys. So if you like this video, please go ahead and like. If you haven't subscribed my YouTube channel, please go ahead and subscribe my YouTube channel.